For centuries, the pyramids of Egypt have been a marvel shrouded in mystery. How were they constructed? How many people did it take to build them? How old are they? We can use these ancient wonders of the world to learn about some wonders of mathematics, prime and composite numbers. The face of this pyramid is a triangle. It has 3 sides. 3 is a prime number. A prime number has only 2 factors, itself and 1, meaning there will be no remainder after you divide. If we look at a model of a pyramid, we can see it has 4 faces, above a base with 4 sides. The number 4 is a composite number. A composite number has more than 2 factors, including itself, 1, and other factors. 4 divided by 2 is 2, nothing left over. That makes 4 a composite number. Here's another example. The Great Pyramid of Khufu is considered the most magnificent of all the pyramids in Egypt. It's located in a region called Giza and covers 13 acres. The number 13 cannot be divided evenly by anything besides itself and 1, that is, without having a remainder. So 13 is a prime number. It has only 2 factors, itself and 1. Archaeologists think the Great Pyramid took 20 years to build. The number 20 can be divided evenly by itself and by 1, and also by 10, 5, 4, and 2. 20 is a composite number. It has more than 2 factors, including itself, 1, and other factors. Every positive whole number except 1 is either prime or composite. The number 1 is neither. Let's visit other countries to find more prime and composite numbers. Soccer is the world's most popular sport. Let's watch these players practice dribbling to learn more about composite numbers. There are 6 players in this drill. Look at them in groups. They're coming down the field in 2 rows of 3. This shows we can divide 6 by 2 evenly. 6 divided into 2 groups equals 3 in each group, so 6 is a composite number. A composite number can be divided evenly by numbers other than itself and 1, meaning it leaves no remainder. We can use another drill to show how composite numbers can be found through multiplication. The 6 men are in 3 groups of 2 this time. 3 times 2 is 6. Anytime you multiply 2 whole numbers, not including the numbers 1 and 0, you get a composite number. Air shows can be breathtaking. We can watch these acrobats in the sky perform their stunning stunts as we learn about prime numbers. Look at these 9 planes, soaring incredibly close to one another, almost as if they're attached. 2 planes separate from the formation. 7 are left. Can we divide 7 by any number besides itself and 1 and end up with no remainder? Let's try. 7 divides by 2 3 times, but has a remainder of 1. 7 divides by 3 twice, but also with a remainder of 1. 7 divides by 4 once, but with a remainder of 3. 7 divides by either 5 or 6 also, but each time there's a remainder. So 7 is a prime number. Here's a formation of 5 planes. Can 5 be divided by any whole number without leaving a remainder? No, except for itself, 5, and the number 1. 5 is also a prime number. A prime number cannot be divided by any number besides itself and 1 without leaving a remainder. Let's head to the vast Sahara Desert, where scientists are studying something small: ants. These scientists are drawing a huge grid in the hot sand to record movements of desert ants. These ants take a winding, indirect path to find food, but they always return home in a straight line. This researcher thinks it has something to do with sunlight, so he's using this filter to change the way the ants see. We can use the scientist's big sandy checkerboard to show prime and composite numbers in a different way. Let's use the squares in the middle. 10 squares this way and 10 squares this way. That's 10 times 10, or 100 squares. Now, let's pick a few numbers, and we'll see how those numbers that are prime can look different from those that are composite. First, try 5. 5 is a prime number. It can be divided evenly by only two numbers, itself and the number 1. There's only one way to show this in a rectangle on our grid. We outline one row of 5 squares. We can show the row up and down or straight across and anywhere on the grid, but it's still just one shape. This is called a rectangular array. The number 5 has only one rectangular array shape. The same is true for all other prime numbers. Take 7, for example. As a rectangle, it can be shown as only one row, up and down or straight across. Now, what if we try the number 8? We can show 8 as 1 by 8 like this, or 2 by 4 like this. The number 8 has more than one rectangular array, so 8 is a composite number. Any number that can have a rectangular array with more than one row is a composite number. Let's try a greater number. 24 can be shown in many ways, including 3 by 8, 4 by 6, even 2 by 12, which would go beyond our grid. Again, 24 has many different arrays, so 24 is a composite number. Whenever a number can be represented with a rectangular array taking up at least two squares on both sides, it's a composite number.